Hi, everyone. My name is Chris Norman, and welcome back to the new Lancair channel, where I'm going to be talking about and building two Lancair 360s over the next couple of years. I don't know exactly how the formatting is going to work, but I hope that I'll eventually get a better camera and a tripod and a microphone so I can have improved audio quality, and also get some help maybe from my son to help me go through the design process, through the construction process. And really, I think where I want to start with on this first video, we'll be talking about some of the fallacies, misconceptions, and information out there. First of all, the Lancair 360 is an out-of-production model aircraft that was originally designed by Lance Niebauer more than 3 decades ago. The 360 started life with several lower models, a 200, a 235, and progressed through the 320. And really, the 360 is nothing more than a 320 kit with a Lycoming IO 360 attached to the firewall. There really are no other differences. There are a few kit design changes that occurred naturally as progression over the years that simplified things, reinforced things, or altered things, ultimately resulting in several modifications both inside the kit itself and also with aerodynamically with the Mark II large tail. And I'll be showing those during the build and construction of the kit. So it'll be some time before I kind of outline all of that. But I think today where I want to start is a discussion about the performance of the airplane and what the expectations are and are some of the fallacies. Now, there are a lot of documents out there, and frankly, a lot of the information is old and has not been updated. There are mostly images of old brochures and documents. Even the construction manuals are non-searchable PDFs because the designs are kind of old. So I would equate a Lancair 360 to something more like a 1957 Chevy Bel Air. It's a classic. It's something beautiful that there are many of out there that can be restored or flown, and some are still flying. And then there are also plenty of kits available still in varying states and conditions that can be acquired. Now, I myself have been reading forums for the past 20 years on Lancair, waiting for the day that I would build one. And I thought I wanted a 4-place, but now that the kids are grown, I really don't see the need for it. Although I may eventually build a 4-place airplane or just buy one, I don't know, for trips to take people on. But really, this is more for me as an enjoyable thing, and a Lancair 320 is an economical, high-speed cruising machine. Because it's a kit plane, you can do lots of work and upgrades yourself. And if you are the builder, then you can do your own annuals as well. With that said, I'm going to run through some of the information that I've been gathering and just dispel some of the rumors. First, is the Lancair 360 unsafe? And I would argue that if the airplane is built true and it's flown by someone with the proper skill set, that yes, it is just as safe as anything else. The big difference is that everything happens much faster in a Lancair 360 than it would in something much slower like a Cessna 172 or a Piper Warrior that a lot of people start out in. So you really have to learn to think ahead in the pattern, to think ahead in planning as you're coming into airports, because everything will happen so fast that you will be behind the 8 ball as you approach an airfield. So that is probably the biggest thing that most people would be shocked with. If you're cruising in at 175 to 200 miles an hour, you're going 50 to 75% faster. If you're doing 200 miles an hour, you're almost twice as fast as you are in a Lancair. So downwinds, turning base final will all happen fast. Or if you're coming in straight, it will happen very quickly. Approach speeds are much higher. And that will get us into some of the design elements. The Lancair 360 was really optimized for use with the IO 320 and with the IO 360. With the IO 320, the airplane performs in the 170, 80 knot range, if I'm not mistaken. I will confirm that later. And with the IO 360 standard 180 horsepower, the airplane does 205, 210 knots. Now, there are several airplanes that have been modified with a supercharger that are hard to find because these airplanes and airframes are being built by individuals. That information is not commercial, and a lot of it is old or antiquated. Although I did find a brochure published by Lancair itself, a marketing piece where they equipped a carbon fiber Lancair 360 version. Yes, there are glass versions, and then there are unicorns, and there are, I don't know how many, but I've seen at least a dozen carbon fiber 360 kits over the past 5 years. And those airframes weigh something on the order of 30 pounds lighter than their glass equivalents. And one in particular belongs to a friend of mine named Jerry, who has the turbo normalized IO 360. It's a Lycoming TIO 360 in a carbon fiber airframe. And according to the marketing information, that airframe at 18,000 feet with that TIO engine performed at 240 miles per hour. And at 24,000 feet, which I was surprised to see that they claimed they went to, that airframe hit 260 miles per hour. Mind you, that's on 200 horsepower, and also missing a bunch of other mods that people have figured out through trial and error and engineering design changes over the year. So one of the challenges with the airframe is the airfoil. The airfoil is a laminar flow, low-speed design, and many people over the years have found ways to milk more speed out of this airframe. But you could expect a standard, normally aspirated, 180 horsepower IO 360 with the gear up, with the standard cowling, to perform somewhere in the cruise speed, 75% power, around 205 knots. Wide open throttle, perhaps 215 knots. And that's about all you can get. With a hot rod engine, there are people with race engines taking these planes at the Reno Air Races that are seeing in excess of 276 miles per hour down low in the pattern. Now, these planes are using a lot of mods in order to milk that additional speed. And one of those is reflexing the flaps, using a negative angle on the flaps to alter the aerodynamics of the airfoil at the wing root adjacent to the fuselage. And it seems that this is worth about 10 knots. Something on the order of -7 degrees is required to make this happen. But it really is to the point that the airfoil on the 360 or 320 series kits is optimized for flight within an envelope. That envelope is somewhere between, say, 8 and 12,000 feet at 200 to 220 knots. And if you get outside of those areas, you have an inefficient airfoil, and you have other aerodynamic deficiencies like with cooling and heating. Since every airplane is built individually, they vary in their actual performance with gap seals and other modifications to the airframe that only some really have closely held secrets or information that's fell by the wayside about how to milk these airframes for additional performance. So what you end up with is a legacy aircraft, an old airplane design from the late 80s, early 90s, that has been optimized for this exceptional performance envelope between 150 or 60 knots to 215 knots that performs very well and does so at an extremely fuel efficient fashion. That the 360 can actually milk upwards of 25 gallons miles per gallon in clean trim in 60% cruise at somewhere around 195 knots. This is exceptional fuel efficiency for an aircraft. And up high, I believe that other people are experiencing Lena peak performance just above 8 gallons per hour at somewhere around 180 knots true airspeed. So exceptional performance. There are a number of challenges in building a Lancair 360, and as this channel progresses, I hope to become better at communicating this to you, adding graphics, and trying to get volunteers to help. I'll have guest speakers that come on the channel to talk about performance improvements and mods and aftermarket accessories that exist. For example, Chris Zavatson has a very pretty cowling for it, and also brakes, which takes me back to one of the safety concerns. The original design of this airplane leaves a lot to be desired for braking performance. And if you look at the accident information recorded by all the insurance companies, you will find that a lot of people slide off the end of the runway and damage their airplanes, including totaling them, damaging the gear, collapsing them all, and totaling the aircraft, prop strike, the whole 9 yards. And Chris Zavatson created a new set of brakes for the airframe that use 3 pistons and have a substantially more stopping power for the design. And if you are flying without these, I would argue that you need to seriously consider looking into the upgrade for these brakes. There are a number of other ones over the course of the time for this show. We'll be outlining those, bringing in guest speakers, talking about the different designs and also the assembly methods, and also showing you tips and tricks for how to put these things together properly, how to jig them, align them, fixture them, and also how to create reproduction parts. They are sometimes very hard to find, and also finding them from the factory can be extremely expensive. And there are a number of kits out there, perhaps in the order of 1,000 existing kits that are unfinished in various states. And if you have the time and patience and the skill set to build one of these yourself, you can build an entire airframe for under $30,000 before you put avionics in it and an engine. So some people that are motorheads might be able to rebuild an old engine. Other people can also deal with just using steam gauges, which are the old dial gauges and vacuum systems, to go low tech and low cost in the airframe. And you can get airborne, I would imagine, with a scrappy person in the $45,000 to $50,000 range, with a rebuilt engine or a low time engine that has been taken off and pulled from someone else's plane, and minimal avionics. Or you can go to the other extreme and probably have $200,000 in the airplane if you go full Garmin glass cockpit with a brand new crate engine and fancy paint job and a lot of upgrades like wing tips and cowls and brakes and everything. So really it's a wide range. But if you're looking for something fun to fly, I look forward to you subscribing to this channel and learning about the Lancair 360 and about Lancairs in general. And lastly, I'll close with this. My name is Chris Norman, and my background is I am an engineer from Texas A&M University and have spent my career designing products like blowout preventers, subsea equipment, valves, commercial light fixtures, you name it, I've been involved in it. And I also have a long history of flying radio-controlled airplanes. So it's a natural thing for me to migrate into flying full-sized airplanes. I'm a roughly 100-hour pilot, did most of my flight training at KGTU in Georgetown, Texas. And I have an aviation passion, and I hope you'll subscribe and follow me for more in the future. Thank you.